The educator Dylan Wiliam once called cognitive load theory, or CLT, the single most important thing for teachers to know. Now that is a massive claim. So today, we're going to unpack exactly what this theory is and why it's become so incredibly influential.
So let's dive right in. We're going to explore this idea of a bottleneck inside our own brains. And you'll see why understanding our own cognitive limits is, well, it's a total game changer for anyone who wants to learn or teach more effectively.
All right, here's the game plan. First, we'll tackle the fundamental problem our brains are up against. Then we'll break down the different kinds of mental work. After that, we'll see CLT in action in the classroom, look at some really important critiques, and wrap it all up with a big takeaway for smarter learning.
Okay, so let's get straight to the heart of the matter. What is this bottleneck that our brains are constantly, and I mean constantly dealing with? It all boils down to this one kind of shocking number, 4. That's it. Research suggests our conscious mind, what we call our working memory, can only juggle about 4 new pieces of information at any given time. This is the critical bottleneck we're all fighting against every single time we try to learn something new.
And here's where it gets really important. You have to understand the difference between these two systems. Our working memory is like this tiny, tiny little sticky note on your desk. But our long-term memory, that thing is like a vast, endless library where we store everything we've actually learned. So the whole goal of learning, really, is to get information off that tiny sticky note and properly filed away in the giant library.
So how does the brain pull this off? Well, it has a secret weapon. It's called a schema. Just think of it as a mental shortcut, a chunk of organized knowledge. By building these schemas, our brain can take tons of individual little facts and bundle them together so they only count as one single item. It's the ultimate hack for getting around the limits of our working memory.
And this is just a brilliant illustration of how it works. I mean, try to hold those 6 random letters in your head. It's tough, right? It takes up pretty much all of your mental workspace. But because you already have a schema for the word memory, those exact same letters become one single, easy piece of information. And just like that, your brain is freed up to think about other things. So, if our working memory is that limited, we have to be really, really smart about how we use it. And this brings us to the 3 different types of cognitive load, because it turns out not all thinking is created equal.
CLT breaks it down like this. First, you've got intrinsic load. This is just how hard the topic is naturally. We can't really change it, so the goal is to manage it. Then there's extraneous load. Think of this as the bad load. It's just wasted mental effort from confusing instructions or a messy layout. We want to get rid of this entirely. And finally, there's germane load. This is the good stuff. This is the effortful thinking that actually builds those powerful schemas in our long-term memory. This is the load we want to promote.
Okay, so this all sounds great in theory, but what does it actually look like in the real world? How do we take these ideas and apply them to a classroom?
Well, one of the most famous findings is something called the worked example effect. It's actually really simple, but so powerful. For beginners, it's way more effective to study a clear step-by-step example than it is to just be thrown a problem and told, go figure it out. This just reduces all that unnecessary struggle so they can focus on understanding the process. And here's another classic example. It's called the split attention effect. So look at the high-load version. The student has to look at the diagram, then go hunt for the text somewhere else on the page, and then mentally stitch them together. That back and forth, that's pure extraneous load. It's totally wasted effort. Now look at the low-load solution. By just putting the text right next to the part of the diagram it's describing, all that wasted mental energy just disappears. It frees up the brain to focus on what actually matters, learning the geometry.
But, okay, how do you get a learner from that initial hand-holding to being fully independent? Well, a really clever technique is called backwards fading. You start by showing a complete, worked-out example. Then, you give them a new problem, but you fade out the very last step and ask them to fill it in. Then you fade out the last 2 steps, and so on. You're gradually shifting the work onto them without ever overloading their working memory. It's a really smooth transition.
But, like any big, powerful theory, CLT isn't the whole story. It's really important that we look at some of the critiques and the nuances to see where the limits are.
Stanford mathematician Keith Devlin gives us this really important dose of perspective. He basically argues that, yeah, managing cognitive load helps, but maybe it's distracting us from something even bigger, motivation. I mean, if a learner just doesn't care about solving the problem, tweaking the instructions might not make much of a difference at all.
And when you really start digging into the academic research, the evidence isn't always so perfectly neat and tidy.
For example, a big review of CLT studies in math back in 2009 found what they called a mixed picture. Sure, some studies showed worked examples were way better, but others found they weren't any better than traditional problems, or that the benefits were pretty narrow. It's just a good reminder that the real world is often messier than the lab.
And that's because, at the end of the day, context is everything. For instance, a strategy that's a lifesaver for a beginner can actually get in the way of an expert. They call that the expertise reversal effect. The theory also needs to be adjusted for really young kids, since their learning is so tied to physical play and exploration. And what I find fascinating is that some research even suggests a student's socioeconomic background can play a role in how helpful these strategies are. It's definitely not a one-size-fits-all solution.
So, where does all of this leave us? What's the big idea we should be walking away with here?
I think this is the most important point of the entire explainer. Cognitive load theory is not about making learning easy. It's about making it smart. The goal is to be absolutely ruthless about cutting out the pointless, confusing, extraneous stuff so that a learner can devote their full, precious, and limited mental energy to the productive struggle, that desirable difficulty that actually builds knowledge that lasts.
And this all leaves us with one last powerful question. It was actually inspired by one of the earliest experiments on this topic. In that study, researchers found that students could solve problem after problem. They looked incredibly busy. But when they were tested, it turned out they hadn't actually learned the underlying concept. So the theory forces us all to ask ourselves, are our students, or for that matter, are we, just being busy, or are we truly learning?